So you can see that these are getting a little more complicated. We have multiple parentheses, and they're more and more difficult to distribute, right? So our hope is that some of those variables can be given away as part of the inner derivative of the other. So if we look at the more complicated piece right here, and we think about the derivative of the inside of that. Well, the derivative of the inside of that is 8x minus 2. So if I want to do this without distributing or substituting, I need to give away an 8x minus 2 dx. You're not allowed to make up a variable. But coincidentally enough, I have some already. And if you look closely, you'll see that if we factor a 2 out of this, I actually need to give away exactly what I have, which I find to be a bit contrived, but you will find that a lot of the problems are like that. You have most of what you need and you're only missing a number. So for this one right here, I already have a 4x minus 1, I already have a dx, I need a 2. So I could just rearrange this guy and insert a new 2. But if I make the 2 up, I have to also multiply by a 1/2 in front to balance it back. And so this piece is going to be my sacrifice right here. I'm going to sacrifice him to the integral gods so that they will let us reverse the chain rule. And we can just treat this entire parentheses like a monomial, add 1 to the power and divide by the new power. So now we have 1/2, that whole parentheses, to the third power over 3 plus c. Then if we just clean that up, our denominator becomes 6, and our numerator is 4x squared minus 2x plus 9 to the third power. Did I forget anything that time?
No, ma'am.
No, excellent. Any questions? So let's pause because I think someone wanted to see this work the other way. For this next example, we have the integral of x multiplied by x squared plus 3 quantity to the 5th power dx. So we obviously don't want to have to multiply that out 5 times in order to distribute it. So what we're going to hope is that we can use that x as part of our sacrifice and get rid of it. Because you do have to get rid of that outside x, or you have to distribute it. But thankfully for us, the derivative of the inside is at 2x. So if I rearrange it and I put the x down here, I actually only need a 2 in order to make a full sacrifice, right? So if I make a 2 up, this piece can be given away to the integral gods, but I will have to balance it with a 1/2. And you are allowed to balance with numbers, but never with variables. If you ever need to make up a variable, you're doing something wrong. You have to look for another way to do it. But if you happen to already have the variables there to use, by all means use them. That allows us to add 1 to the power, so that will become x squared plus 3 to the 6th divided by 6 plus c, and the 1/2 stays out front, comes along for the ride, and that brings us to x squared plus 3 all to the 6th over 12. Perfect. So once you do like 6 or 7 of these, they really do get faster, and your brain starts to see the pattern. You start immediately looking for that derivative of the inside to get away. And the nice thing is you could check it by doing the chain rule to that. 6 times 1/12 down 1 on the power times the derivative of the inside, and it should go back exactly to the original.